Hello everyone. So, I just want to tell you all that you all rock, very much so. Here's my slide to say thank you for being so flexible and working with me. Miss Mia was sick today, and thankfully Mrs. Mormon jumped in and took over there for a little bit while I thought I'd be back in time, and as she started to puke on the way home, I thought, oh, this isn't going to work. So, we will have class on Thursday. I already got it rearranged, so we will be talking on Thursday probably about the lab. So today what I'm going to do, no video on because I want to have the whole screen here so you guys can see what we're looking at. So we're going to just review today pretty much about electron configuration. But I did want to say thank you so much for being awesome. That's my little happy dance right there. You guys seriously are totally awesome. So let's go ahead and let's get started. Let me pause real quick. Alright, so for agenda today, we are going to do a pre-learning check, which is located in your course. Just check that out. So go ahead, and once we get to the next slide, you will do that. We're going to review some material. We're going to practice building atoms with a website that's already in your course, and practice reviewing electrons, and then do a post-learning check. So what I want you to do is go ahead and go to your link. It will look like this when you get there. So what is the electron configuration for beryllium? What is the noble gas configuration for argon? And what is the correct orbital box diagram for gallium? And that looks like this. So you can go ahead and you can pause this, figure that out, do those 3 questions, hit submit, and then go ahead and hit play again. Alright, so quick review. What we have done is we have done 2.11 Bohr model. We talked about the guided notes, the first part in Class Connect, the second part in a video. So you'll see that video, you'll see the answer key after you submit to the Dropbox and after you complete the submission quiz, quote unquote, the true or false quiz. 2.12 we discussed in a recording that I posted and videos. And again, make sure you submit your guided notes to the Dropbox, fill out the submission quiz, and you get access to all of that answer key stuff. 2.12, same thing. And then we're on to 2.12B, and now we're on to 2.12C, which is electron configuration practice worksheet. Do the same thing again, and then you will have the answer key. So I can see when you guys watched, let's say, videos that I post. So like my morning mashup videos, I can see how many students actually watch those. I noticed yesterday 90 of you guys had listened to my beautiful singing voice, right? But I do notice that on the morning mashup videos, there's not near as many. Remember, I don't want to say it's mandatory, but it's mandatory. It's not an option, let's put it that way, to watch the Monday morning mashup video, the Friday finishers video. I rarely send K-mails. I don't post a ton of news, right? I do that as the overview for the week, make sure you know what's going on, and then to wrap up the week. So the most they are is usually 5 minutes, so we're talking about 10 minutes out of your week. You have to watch those, okay? So this is going to be my one reprimand of make sure you watch those videos, make sure you listen to that communication, okay? Like I've said all semester so far, we do a lot of things differently. We don't just do lesson quiz, so it's really important that you do those because I get a lot of K-mail questions with things that I've covered in those videos. So just make sure that you're taking the time to do those. All right, so now on to the fun stuff, right? All right, let's look here. So, atomic orbitals. What are atomic orbitals? So at this point, what you're going to do is you're going to stop and you're going to write down on your PowerPoint or your guided notes, whatever, write down what atomic orbitals are. What are principal quantum numbers? Then, if n is equal to 1, how many sublevels are there? N equal to 2, 3, and 4. Now this stuff should all be a review at this point. You should have watched the CC recordings, you should have watched the videos. Not to say you have it all memorized or learned yet, but it should be review. If it's not review, take the time to watch all of those things. Okay, so let's look. I'm going to go ahead and I'm going to get a pen here. All right, so we have atomic orbitals, right? So what these orbitals are, and I know you guys have seen this stuff if you watched the Class Connect recording from last year, but they're these 3D regions around the nucleus where the electron's probably located. And what's the percentage? Well, about 90% probable that you're going to find the electrons somewhere in this orbital, right? Okay, why did they get 90? It's just random. Like, that's just what they chose to use. So the easiest one to look at is the s orbital, right? The s orbital is spherical, okay? So anytime you have an s orbital, it's spherical. So let's say this is a 1s right here. So this 1s, if you notice, if you look really closely, you can see that it's actually darker. It's more dense there in the middle. So that means you're going to have a higher probability of actually finding the electron in that more dense area. And notice how nice and round this is? Well, that's because that's the 90% probability range, right? There's still a 10% chance we could find the electron outside of this, but 90% probable we're going to find it in here. And again, like I've talked, how do they get these images? Okay, so what it would be like is if you sit there and you took a picture over and over and over and over like a gazillion times, right? Then you're going to see and lay them all on top of each other. This is what you get, okay? So we have S. This would be like a P, and then we'll look at these other ones too, okay? So that's our atomic orbital. It's that 3D region around the nucleus. So this principal quantum number, so we call that N. So that N indicates size and energies of the orbitals, okay? So we have a 1s, we have a 2s, we have a 3s. So this 1, 2, and 3, that's the principal quantum number, the N. The larger that N gets, the bigger the size, and the bigger the energy, the more energy. Okay? All right, so if N is equal to 1, there can only be one sublevel. Now remember, sublevels go S, P, D, F. Some poor dumb fool, right? That's not nice, but that's how I remember it. There's a few other ones too that you guys can come up with or have come up with. I'll share those. All right, so if N is 1, there can only be one sublevel. So that means we can only have a 1s. There's no such thing as a 1p, a 1d, or a 1f. With me? If N is 2, you can only have 2 sublevels, so that would be S and P. So there is no such thing as a 2d, and there is no such thing as a 2f. Okay, 3, S, P, and D, and of course 4, you can have S, P, D, or F. All right, moving right along. And at any point, whoops, pause this if you need. All right, so review. S, number of orbitals. So S has one orbital, okay? One orbital, one spherically shaped orbital. How many electrons per orbital? All orbitals can hold 2 electrons. So the total number of electrons in an S sublevel is 2. All right, let's look at P. There are 3 p orbitals, py, px, pz. So P has 3 orbitals. There is always 2 electrons in each orbital. So it can have a total of 6 electrons, a p orbital. All right, let's look at D's. D, 1, 2, 3, 4, 5. D has 5, so the sublevel of D has 5 orbitals. There's always 2 in each, or a max of 2, we should say, so 10. And then we got F, and there is 7 orbitals in the F sublevel, 2 in each, total of 14. So each orbital can hold 2. Do not forget that. Each orbital can hold 2. All right, so here was just some visuals. So right here we have our S, right? 1s, 2s, 3s. The bigger that principal quantum number, the larger the orbital, the higher the energy. Okay? All right, P right there. This, I always like this visual right here because you can see the PX, PY, PZ, and then you can see it all together. So those would be P. And then D's get more complicated, and then of course F's get really complicated. But these are nice visuals. Here's a very cool, so you have right here, 1s, 2s, 3s, right? And then you have the P, the P's. I love this visual. It's just a good visual. And then of course you have your nucleus in the middle. All right, so we are going to practice building atoms. So I will get it pulled up here so we can look at this together. Go ahead and you're going to be able to go, you'll use this website if you haven't already, and we're going to practice building. All right, so we are going to look at this together, and this will be an awesome, awesome visual. All right, so we're starting with helium here. So what we're going to do is we have to drag our orbital first into here, and then we'll add electrons, and it'll fill up this box diagram right here, and then we'll see if we did it correctly. So, helium. Well, it always starts with what? 1s. Helium has 2 electrons. We know that each orbital can hold 2 electrons. So this is a 1s, 1 meaning it's the lowest energy, the smallest size, s meaning it's spherically shaped and there's just 1 orbital there. So 1 electron can go in there, 2 electrons can go in there. So notice we're going to fill up the 1s first. So we have 2 electrons, they're filled up, and the 1s can hold 2. Let's see if we're done. Perfect, let's try the next. Okay, carbon. Always start with 1s. We have 6 electrons we have to place. So our s can hold 2 electrons, so 1s. Now after that it goes 2s. Notice it's bigger, and this is actually going to be higher energy. And notice these right here are in line with energies actually. So the s can hold 2 electrons. Okay? So after that we go 2p. Now, normally we wouldn't actually ever draw the shapes like this. We would draw the boxes, and when we draw the boxes, we actually would draw all 3 of them to start with, and then we'd fill them up. But I don't think this one has you do it that way. It'll have us, maybe it will. Let's see. Yep, so this one doesn't want us to add that 3rd box. It thinks we're going to fill it, but we're not. So let me go ahead and I'll reset here. We'll start. So 1s2, 2s2, then we're going to go 2p. So notice if I put an electron in one of the p's and I go to put an electron in another p, it's not going to let me. Why doesn't it want to let me put an electron in the same box? Well, because the electrons will fill up single first and then pair up. That's Hund's rule. So it's going to go in a different p orbital. So now we have 6. They don't pair up. Remember, they're both negatively charged. So they don't want to be paired together. They're going to be as far away from each other as possible. So we're done with that. We have 6 placed. All right, let's try one more. And then you guys can play on your own. I think there's a few more to do. So 1s2, 2s2. So 2p, we're going to do the x first, then 2py, and then 2p z. Okay, so we've had 2, 4, 5, 6, 7 electrons filled. Okay, so now it doesn't matter which of these is filled up next because they're all equal in energies. So you can fill up any one you want next. They're all equal in energies. So 2, 4, 6, 8, 10. We have one more. So next comes 3s. And let's put 1 for 3s. So double count. 2, 4, 6, 8, 10, 11. 11. Done. Perfect. Okay, so we're going to stop there, and you guys can go ahead and finish the next, the last one there, argon, by yourself. Okay, hopefully for argon, you have them all filled up, and you fill them up singly first, and then you paired them together. And you're done. Okay, so this recording will be over. You will have a second video to watch to practice with the electron configuration.